Okay, so today is lesson 7.4, solving polynomial equations in a factored form. So what does it mean to factor? Well, if you're taking something and you're pulling it out, you're factoring. So let's take distribution, for example. If you have 3 times x plus 4, you know that you distribute by multiplying 3 times x and 3 times 4, and you get your answer. Well, this is taking a factoring of something and pulling it out. So this is 3 times x, and this is 3 times 4. Look for what they have in common and pull it out. And then you end up with a 3x plus 4. Now, when we're doing this, we're actually looking to solve a problem. So when you're looking to solve a problem, you're looking to do it from factored form, because it makes it really easy to do since we like to use the zeros. So for example, this x plus 2, I'm going to set that equal to 0. And what happens is you have a number times 0 to equal 0. That's the only way that could be possible. 5 times 0 is 0. 0 times 0 is 0. 1 times 0 is 0. They're all times 0, so therefore one of these has to be 0 or both. So I'm going to split this apart because I know that I have that a possibility to be a 0, and this is my other possibility to be 0. So what values would make that true? So I already have the answer for this one. Makes it kind of simple. But this one I just subtract 2 and do a little one-step problem to get -2. And then it's all set. Those are your solutions for that particular polynomial. So if the product of two real numbers is 0, like here, then at least one of these numbers is 0. So in order to solve for it, I need to figure out what possibilities there are to do that with. So if I'm looking to solve these equations, I have 2x. That could be equal to 0 because that's being multiplied by the x minus 4. So I just could take the 2x, I set that equal to 0, and the x minus 4 equal to 0. I divide by 2 on both sides, and x is equal to 0. First possibility. The second thing is add 4, and x equals 4. Another possibility. When you have two binomials multiplied together, you just again split them. Where they're being multiplied, that's where you split them. So x minus 3, x minus 9, and you're going to set both of those equal to 0. Add the 3, and x can equal 3, which would make this true, or x can equal 9, which could make this true. And the better you get at this, the faster you'll get at it, because you'll notice that 9 minus 9 is 0. So when you're doing problems, just think about that. 3 minus 3 is 0. 2 times 0 is 0, and 4 minus 4 is 0. So if you look at this, you can go, okay, well, I know this is going to be x equals 0. And what number would that be? Well, it'd be 1. 1 minus 1 is 0, so x equals 1. And like I said, after a while, you get really, really fast at these. So 3t equals 0, t plus 2 equals 0, t equals 0, or t could equal -2, because a -2 times 2 is 0, or sorry, -2 plus 2 is 0. Almost said that wrong. So this right here, z minus 4. So z minus 4 equals 0, or z minus 6 equals 0. So add 4 to both sides, and you'll get z equals 4, or z equals 6 when you add 6 to both sides. So let's take it another step further. So those are all one steps, right? One little step to get to your next answer. Literally like divide by 3, or add 2, or subtract 2, or add 4, or whatever it was one step. What happens if you have more than one step? So in that case, you do 2 steps. You set both of them equal to 0. Again, this is where they're being multiplied. and that product or multiplication has to be 0. So you subtract your 7. You do that both times. Whoops, sorry, one of these was minus 7, so we'll add 7 here. I miswrote it. And this is 2x equals negative 7, and 2x equals 7. So when I divide by 2, I get x equals negative 7/2, or it could equal positive 7/2, because either answer is going to make that equal to 0. Now, the really cool thing about problems like this, remember this is x minus 1 times x minus 1, because it's x minus 1 squared. So really, you only have to do it one time. Add your 1, x equals 1. And on this one, this would be considered a cubic. So there are 3 x's, and x times x times x would be considered x cubed. So there could be potentially 3 answers here, which there are. So x is either going to equal negative 1, x is going to equal 3, or x is going to equal 2. Again, these are all one steps, just like I did above here. Because 3 minus 3 is 0, 2 minus 2 is 0, and negative 1 plus 1 is 0. And I would like for you to try these problems at the bottom real quick. Setting them equal to 0. I would pause this and then come back and check your answers just a moment. Make sure you got the skill. So 3, 2, 1, starting back up. So this would be 3s plus 5 equals 0, and 5s plus 8 equals 0. So subtract the 5, and you get 3s equals negative 5. Subtract the 8, and you get 5s equals 8. Divide by the 3, and s equals negative 5/3. Divide by the 5, and s is going to equal negative 8/5. And there's your 2 answers. This one I only have to do once. Makes life handy, doesn't it? So subtract the 7, and you get b equals negative 7. And this one has 3 different types of answers here, because none of them are repeated. So we're going to do 3 different answers. So d could either equal 2, negative 6, or negative 8. So different ways to write stuff, right? You could write those 2 answers. You could write the 2 answers together. You can write them with commas separated. You can write them out. Doesn't matter, as long as you have them all accounted for. So, finding the greatest common monomial. This is a little bit different. You're going to be pulling out some numbers here. So if you have, for example, 64, and you're wanting to break that number down, what you're looking to do is you're looking to go, well, that's 8 times 8. So that's a breaking down a number. You're doing the same thing here. You can use factor trees if you want to. You don't have to. Eventually, you're going to get so good at this, you're not going to need to. But you have 4 times x times x times x times x plus. There's your plus right there. Plus, this is 4x. I'm just spreading it out. Plus 4 times 6 times x times x times x. Now you might wonder how I knew to do 4 times 6. Well, I know that 24 could be 8 times 3, 4 times 6, 2 times 12, 1 times 24. Lots of variations on that. But the reason I chose the 4 times 6 is because of the 4 here. I wanted them to have something in common. So what you're looking for here is you're looking for, what do they have in common? They both have a 4. Okie dokie. And they have 1, 2, 3 x's, 1, 2, 3 x's. So what was left over is what you're looking for here. And if you take a look at it, this just has an x left over, right? And this one just has a 6 with a plus sign in between. So x plus 6 and 4x to the third. And voila, you just factored. So if I was to multiply this back out and distribute, this would be a answer. Okay, so here, 8 times y times y, 8 times 3 times y, Again, I chose the 8 times 3 because I knew I had one in my other problem and I knew that would work. Again, you're going to get really good at this after a while. So I got my 8, I got my y. These are in common. What was left over? Y minus 3. So you have y minus 3, and you're pulling out that 8y. You multiply this back out using distribution, you get this as your answer. All right, I'd like you to pause for just a second and give this a whirl. I will tell you on this one, though, you do need to, before I pause you on this, you do need to subtract the 15n so that you can make this equal to 0. You do that by subtracting 15n from here and subtracting 15n from this side. It does need to be equal to 0 when you factor so that you can have everything on the same side. So pause, 3, 2, 1, back to me. So this is going to be 2 times x times x. I'm going to write this out for you just for starters so that you guys can kind of get an idea what I'm doing here. And 2 times 4 times x. They have in common a 2x, x plus 4 left over. So pull that out. And you have your answer. This one would be 2 times 3 times n times n. I knew I was going to use that because 3 goes into 15. So 5 times 3 times n. I have a 3n and a 3n. Pull those out, and you end up with 2n minus 5 times your 3n. And you're good to go. So if you're solving the equation, you're doing the exact same thing. You're just going to take it one small step further. And I'm going to go through these quickly because I'm running out of time. I only have 4 minutes left on this video maximum. So this is going to be a plus 5 equals 0, a equals 0, or a equals negative 5. This one is going to be 3s. I'm going to be left with an s minus 3 equals 0. So s equals 0 or s equals positive 3. And last one, make sure this is equal to 0. 4x squared minus 2x equals 0. So I know I can pull out a 2 and an x. And you have a 2x left here. If you pull the whole thing out, remember you can still multiply that by 1. So 2x times 1 is 2x. So it kind of stays there almost like a placeholder, but it's not. It's actually a number there. So equals 0, 2x equals 0, 2x minus 1 equals 0. You know this one is 0. And this one you're going to get 1/2. Okay, so hopefully that made sense to you, especially with that 1. You can model things too. So for example, if you have an arch for a fireplace and you got a big old roaring fire here and it's just going on and on and on, this is like at negative 18 and this is at positive 18. So how far apart are these? Remember when you're looking for distance, distance is always positive, so it's using the absolute value, which is 36 inches. And similarly, if you have a mine shaft, I don't know if anybody's been in a cave or a mine shaft lately. I've never been. But -4, +4, on a graph, this would be what we call the zeros of the equation, because there would be an axis going through here. And this would be -4 + 4. Remember absolute value, the distance from 0. So this is 4 + 4, or 8 feet. And you're finding the distance of the opening. Okay, hopefully that kind of solves some things for you as far as how to factor a little and solve for 0. And of course, if you have any questions, please let me know, or if you need another example on something.